So a lot of the times when we're doing limits, you're going to have two different functions, and both of those limits have to exist in order for the limit to work. We're going to look at a couple, actually, interestingly enough, not the first example, but some other examples, where one of the limits of the functions doesn't exist, but a composite of the two does exist. All right? So let's take a look. So these examples I stole right off of AP Central. They have some good questions in there. So here, I'm going to make this smaller so we can see everything. All right. So the graphs of function f and g are shown in the figures above. Which of the following statements is false? Everybody's favorite, where it's like, wait a minute, which ones are false? All right. Is the limit as x approaches 1 of f of x equal to 0? Yes or no? Crowdsourcing. Go.
Yes.
Yes.
Yeah. Is f of 1 equal to 0?
No.
No. What is that called?
Removable discontinuity.
It's a removable discontinuity. All right. Next one. The limit as x approaches 2 of g of x does not exist. True or false? True, because the limit as we approach 2 from the left of g of x is 1, but the limit as we approach 2 from the right of g of x is negative 1. All right. The limit as x approaches 1 of f of x times g of x plus 1 does not exist. Well, let's see. As x approaches 1, what does f of x approach? 0. And g of x plus 1, that is g of 2, what is that? But again, we're doing the limit. So as x approaches 1, our internal part here is moving towards 2. And does the limit at 2 of g of x exist?
No.
No. So this is true also. This limit does not exist because one of those two limits doesn't exist, throws the whole thing into does not exist territory. Well, we're really hoping that this one is false now. The limit as x approaches 1 of f of x plus 1, that would be f of 2. I don't know what it is, but it exists. And does the limit as x approaches 1 of g of x exist?
Yes.
Yeah, let's see. So does this exist? They're all true? Have I totally messed this up? Probably. That one's true. But let's take a look at this one. Okay? All right. So what is the limit as x approaches 1 from the left of f of x times g of x plus 1? As x approaches 1 from the left, f of x approaches 0 times g of x, we're going to be approaching an interior of 2, right? That's 1. That's 0. And the limit as x approaches 1 from the right of f of x times g of x plus 1, f of x still approaches 0. As we approach x is 1, x plus 1 approaches 2. from the right, and as we approach 2 from the right, this approaches -1, which is also 0. The left-hand limit and the right-hand limit agree with one another. So when one of the limits doesn't exist, you can't just go, yeah, I'm just going to throw the whole thing out. This one is actually false. And I kind of purposely led you astray there, because that's what people think. They're like, oh, this one doesn't exist, so the whole thing doesn't exist. You have to look from the left and from the right to see what's going on. All right. Let's take a look at this next one. Make that a little bigger so I can actually read it. The graphs of the functions f and g are shown above on the interval from 0 to 5. Let h be a function defined by h of x is equal to g of f of x. Find the limit, the value of the limit as x approaches 3 of h of x, or explain why the limit doesn't exist. Use correct limit notation in your answer. Okay, the first time I saw one of these, I was greatly confused. Because here's what I did. I was like, okay, as x approaches 3, f approaches what? 2. And so I went, all right, the limit then will be, what does g approach as f of x approaches 2? And I went, oh, there is no value. So I put it does not exist, which is the incorrect answer. So here's what we're going to do. Let's look at what is the limit as x approaches 3 from the left of f of x. It's equal to 3, right? We all agree with that. But notice it's approaching 3 from above, right? It's a number greater than 3. And this is not standard notation. I don't know what standard notation is, but I write it that way. It's approaching 3, but from above. 2, sorry, thank you. We're approaching 2 from above. And the limit as x approaches 3 from the right of f of x. Note that that f is approaching 2 from above. So then the limit as x approaches 3 of h of x is the same thing as the limit as x approaches 2 from the right of g of x. Since both the left-hand limit and the right-hand limit of f approached 2 but from the right, values greater than 2. So that's going to be 4. So when you have a limit that doesn't exist, you got to explore a little bit deeper. Now, if you have the sum of 2 limits, well, if one of them doesn't exist, game over. Or the difference. But here, when you have a composite function, like we had there, or if you're multiplying, or dividing for that matter, it's possible that the limit could still exist. All right, let's take a look at this one. The table above gives values of the function f at selected values of x. Which of the following conclusions is supported by the data in the table? All right, so the first one, the limit as x approaches 4 of f of x is 6. Is that supported by the data in the table?
No.
No, because 4 is right in here someplace, right? That approaches 6, but not so much the right-hand limit, so that's not it. And then they're like, oh, so maybe it approaches 7. And you're like, well, only from the right. The limit as x approaches 4 from the left of f of x is 6, and the limit as x approaches 4 from the right of f of x is 7. Now, when they say that, notice the way that they worded the question. They didn't say which of the following is true. They said which of the following is supported by the table. Do we know for sure either of these limits by looking at the table? No. It's possible, but we don't know for sure. Well, let's take a look at this one. The limit as x approaches 4 from the left of f of x is 7. Oh, they did it backwards here, didn't they? So that's not so much it. All right. Questions about that? All right, on to page 3. Table above gives values of a function f at selected values of x. Which of the following conclusions is supported by the data in the table? So, does the limit as x approaches 6 if f of x equals 0? No. You can't average those out, right? The limit as x approaches 6 if f of x is equal to 6. Well, yeah, that's just crazy, right? Because 6 is here. Or 10. I don't know where 10 came from. I'm like, what? The limit as x approaches 6 if f of x does not exist. That's supported by the table. We got really close to 6, and we have two vastly different values. All right. I'm going to make this a little bit smaller. Let g be a function that is increasing for x less than 1 and increasing for x greater than 1. If the limit as x approaches 1 of g of x is equal to 5, which of the following could represent the function g? So there are 3 different choices. Now, for me, you guys have all been in my geometry class. I'm a picture guy. When they tell me all this information, I'm like, it'll be a lot easier for me to get all that if I draw a simple picture of that. So I need a function that is increasing for x less than 1, decreasing for x greater than 1, and as we go towards 1, this goes towards 5. 1, 2, 3, 4, 5. Now, do I know what happens at 1? No, I do not. Do I know what kind of a function this is? No, it could be piecewise linear, it could be a quadratic, there's lots of things that it could be, but it's got to be increasing for x less than 1. That means it's got to be going up, and then after that it's got to be going down. That's the simplest.
So it's double increasing now.
Oh, it says increasing and increasing. Remember we talked last week about anticipating? That's what I just did. And that one I wasn't doing it on purpose. Right? Most of the time when you see this is increasing, you expect that the other thing is going to be decreasing. All right. So I'm going to actually start with this graph because I'm like, oh yeah, that could be it. Kind of looks like my graph. All right, let's look at this one. Oy vey. So let's take a look and see if the limit is actually equal to 5. So if I take the limit as x approaches 1 of x squared plus 3x minus 4 over x minus 1. Because we don't care what happens at 1, we only care what happens near 1. That'll be equal to the limit as x approaches 1 of, let's see, this is x minus 1 times x plus 3 over x minus 1. The x minus 1's happily cancel because except at 1, this is equal to 1. As x approaches 1, this approaches, oh, it's 4. If it wasn't for that, this one would be great. All right, let's take a look at this. We have a function that, is it increasing as we approach 1? Yeah. Is it increasing after we leave 1? We're like, well, it suddenly is down at negative 5,000. That's all right. We just want it to be increasing after that, and it is. Is the limit as x goes to 1, 5?
Doesn't look like it, but
Yeah, the table certainly doesn't support it, because remember, the limit, we don't care what happens at 1. So we're looking at this and you're like, not so much. So it's just 3. Okay? Any questions about that?